We present geometric scale estimation using multisensory cues in virtual reality. Virtual reality environments present a fundamental perceptual challenge. Accurate object scale estimation remains an essential yet incompletely understood aspect of spatial cognition. This study examines how multisensory integration influences three-dimensional object scale estimation in large scale of virtual environments. In this study, we established a design rationale for measuring estimation accuracy. The geometric shape used in this study was a cube, and each dimension was set to approximately match the full span of a single human hand for intuitive interaction. To evaluate the scale of the other cubes relative to the reference cube, we defined the comparison cube. This was designed to address the question, how different is the scale compared to the reference cube? The first variable for the study is sensory condition. Participants first experience the reference cube, then judge each comparison cube as smaller, same, or larger in scale by observing visually. In the only visual condition, they use their vision only. In only haptic, they use touch with invisible hands and reference cube. And in multisensory condition, both vision and touch were available. The second variable is the estimation field. We introduced 3 levels of depth with a maximum distance of up to 5 meters. Additionally, vertical variations was implemented by defining high and low positions from the participant's eye level. Based on this setup, a total of 5 distance spatial positions were designated for the placement of the comparison cube. The final variable is scale variations of the reference cube. The 3 scale levels, small, medium, and large, were defined based on the threshold identified in the pilot study, where participants' ability to distinguish scales through haptics was evaluated. Next section is about the experiment. To provide haptic feedback, we used commercial haptic gloves, which name is HapX. In the pilot study, we conducted a J&D test to find out how much smaller or larger a cube needs to be for people to notice the difference from the reference cube. Based on the result of the pilot study, we designated the scales for the small, medium, and large cubes. Accordingly, the comparison cube was redefined as either smaller, identical, or larger in scale based on each level of the reference cube scale. This allowed us to observe whether participants tended to overestimate or underestimate perceptual scale in the main study. In the main study, participants sequentially experienced the reference and comparison cubes depending on the sensory condition. They then responded by pressing a button to indicate whether the comparison cube felt smaller, same, or larger based on their mental model. At close range, visual and haptic cues combined gave the best accuracy, while mismatched cues at far distance reduced performance. Surprisingly, haptic feedback alone improved estimation, highlighting its future potential. At high and low vertical positions, participants show more uncertainty and relied more on their intuition. Large-scale cubes were often underestimated, likely due to perspective distortion from vanishing point projection in mental scaling. As distance increased, multimodal sensory led to more extreme over or underestimation. This research suggests that spatial position and sensory modality have a greater impact on scale perception than object size itself, offering practical insights for designing VR interfaces in large-scale environments. Finally, our contributions are as follows. First, we investigated object scale perception by utilizing both visual and haptic cues, while also accounting for overestimation and underestimation tendencies. Second, we employed a broader range of spatial configurations to more comprehensively cover variations in perceived scale, including vertical positions such as high and low. Third, we proposed design guidelines for future VR environments that consider both sensory conditions and spatial positioning to support more accurate scale perception. For more information, please refer to our paper.